Okay, so our implementation of ArrayList is only going to hold strings, and I said that you should use an array for the internal storage. So you could have public class APList, and then you're going to have a string array to store all the data. One of the limitations of arrays is that they're fixed size when you create them. So that's why our constructor has an input that's going to tell us what the maximum capacity is. And so there inside the constructor, we're going to actually make the string array to be the maximum capacity. So let's say over here in a tester, I declare an APList variable, and then I run the constructor with an input of 1,000. So internally, that's going to initialize this array with indices between 0 and 999, so that's length 1,000. And if I say list.add a, I want to take that a and save it here. If I say list.add b, it's going to put the b here. But then, if I say list.remove 0, that's going to remove the thing in index 0, and then everything else is going to get copied down. So b is going to get copied here. Whatever was here is going to get copied over top of b, and so on to the end of the list. So after we remove, we've got just b in index 0, and then nothing else in the rest of the indices. In case you didn't know, when you first create your array, it's full of the value null. So that's what's in the rest of these. My piece of advice is you need a way of keeping track of where is the end of the list for you. Not the end of the array, but the end of the values that have been stored inside the array. So when we start here, so I'm going to call it next. So if I have an int called next that starts at 0, in my mind, next means the next open location in the array. So before we've added anything, so let's pretend there's no b here, it's all null. So before we've added anything, the next open location in the array is index 0, because we haven't put anything there yet. As soon as we add a, we'll put a there, and then we'll add 1 to next. And so now the next free location isn't 0, because we've put something there. Now the next free location is 1. And then if we add b, we're going to add that at the next free location. So we're going to store b inside index 1, and then we'd add 1 to next. If you ever end up removing something, you're going to copy everything else backwards in the array, and then you would subtract 1 from next because you've removed something, and so next would go back down again. So I think you'll definitely want a private int next variable. When you add something to your array list, you may need to shift everything to the right. So in other words, let's say that I've got a list that's full of stuff, and I want to insert z at some particular index. If there's already things there, then what we're going to want to do is copy a here and b here and c there like that to make enough room to put z in. So I know I'm going to need a loop of some kind. But where are we going to loop? Notice that if I do this in the most straightforward way, like I think about I want to put z here, so I'm going to copy a right there. If I do that, then I've destroyed the value of b, because I've copied a directly on top of b. So instead of starting here and copying forward, we actually want to start from the end and move backward. So let's start from d here. Or let's actually pretend this is the end of the list, okay? So there is no rest of the list. If I'm going to insert an element z here, everything else shifts, and this d is going to end up disappearing because there's nowhere to shift it. So I'd want to start one smaller than the end of the list, and I'm going to take c and I'm going to copy it up in the list. So now this is c. And now it's safe for me to traverse backwards, and now I've got b, and I can copy it over top of c, because I've already moved c. And now I can go backwards, and I can take a and copy it over top of b. And now this spot is empty, and I can insert z there. So that's the idea. So we're going to have I go from last element to index n. So we're looping backwards from the last index to index n. And we want to do something like this. We want to have the array at index I minus 1, and we want to use that to copy it over top of index I. So array index I. So we're copying that way. And then eventually we get to the end here, and at the very end we can say array at index n gets whatever the new value is. So I've kept this intentionally a little bit sketchy because I want you to have to think it through. But I think the main thing to think about is, for your loop, where does your loop index start? What direction is it moving in? And then once you're inside the loop, if your index is pointing at a specific value, do you want to take that value and copy it somewhere? Or do you want to take a value that's next door and copy it to where your loop index is? So there's kind of a lot of choices to think about. So you want to think about that when you're shifting right. You also want to think about that when you're shifting left. Good luck, everybody.